Nitrogen pressure in this soil is already beyond what long-term crop systems can safely absorb. A plant bred to feed billions should be able to survive where it was born. But it doesn't. And yet, it feeds the world anyway. Soybeans are one of the most productive crops on Earth, a primary source of protein and oil for humans and livestock, embedded into almost every global food system, and still, they rarely grow where they came from. Not for long, not safely, not without consequences. This is not a story about farming mistakes or bad land management. This is a story about a biological system that works only by violating an expectation that feels fundamental. Crops are supposed to settle. Roots are supposed to stabilize. Soil is supposed to recover. Soybeans quietly refuse all three. When soybeans are planted repeatedly on the same land, yields drop, diseases accumulate, microbial balances collapse, and the soil turns hostile to the very organism it just supported. This is not a flaw in modern agriculture, it is a built-in limit. Soybeans actively reshape the microbial community around their roots, recruiting nitrogen-fixing bacteria that convert atmospheric nitrogen into usable forms, an ability that sounds like a gift until it concentrates stress into a narrow biological channel. The soil becomes chemically altered, biologically biased, and increasingly specialized for a single interaction that cannot sustain itself indefinitely. Pathogens adapted to soy proliferate faster than the plant can evolve resistance. Nutrient cycles tighten, then snap. What looks like abundance is actually compression. A system pushed toward efficiency loses slack. There is no safety margin. The longer soy stays in one place, the more it undermines the conditions that allow it to exist. Rotation is not optimization here, it is escape. Soybeans survive globally because they are constantly moved, geographically and temporally, from field to field, country to country, continent to continent. They are productive only as long as the damage they cause remains distributed, diluted across landscapes large enough to absorb it. This creates a disturbing inversion. Stability does not come from roots staying put. Stability comes from leaving. The crop that feeds the world behaves less like a settled organism and more like a biological extraction process, pulling nitrogen, carbon, and microbial labor from soil ecosystems faster than those systems can reset. When soy arrives, it performs efficiently. When it lingers, it destabilizes everything around it. This is why soybeans dominate global trade routes, but rarely define local agricultural identity for long. They are welcome guests that cannot stay. Their success depends on a continuous expansion outward, into new soils, new regions, new ecological contexts that have not yet been exhausted by their presence. The unsettling part is not that this system exists, it is that it works. It works precisely because no single place bears the full cost. Soybeans do not collapse ecosystems instantly. They erode them gradually, predictably, and invisibly, until the only viable solution is movement. From the outside, this looks like agricultural progress. From the inside, it looks like a living system designed to burn through its environment and relocate before the damage becomes fatal. This is not an accident of modern farming. It is the biological logic of soybeans, scaled up to planetary dimensions. And once seen clearly, it becomes difficult to decide whether this is a crop sustaining humanity or a system that survives only by never being allowed to settle. Soybeans are often described as restorative, a crop that gives back to the soil by fixing nitrogen, as if their presence should heal agricultural land over time. This assumption feels reasonable. It is also incomplete in a way that matters. Nitrogen fixation is not a neutral gift. It is a targeted biological transaction, one that accelerates some processes while quietly exhausting others. The bacteria that form symbiotic nodules on soybean roots convert atmospheric nitrogen into ammonia, but this conversion demands energy, carbon compounds, and micronutrients drawn from the soil at a steady, uncompromising rate. What appears as enrichment is actually a redistribution under stress. Nitrogen increases while other elements drift toward scarcity, and microbial diversity narrows as communities reorganize around a single dominant interaction. The soil becomes efficient, then fragile. This is where the contradiction sharpens. Soybeans do not simply use the soil, They reprogram it. It is a visual solution that behaves like a glitch, surviving not because it is elegant, but because it destabilizes others faster than it destabilizes itself. In evolutionary terms, this is a dangerous strategy. It assumes the predator will always be the one to fail first, and yet, generation after generation, that assumption holds. The stripes remain, not as decoration, not as signal, but as a reminder that survival does not require beauty or efficiency, only that someone else makes a mistake before you do. The stripes are often explained as a defense against predators, but that explanation quietly misses the more uncomfortable pressure shaping this body. Lions kill quickly. Infection kills slowly. In the savanna, it is not the visible attacker that extracts the highest long-term cost, but the small persistent ones that feed without resistance and leave damage behind. Blood-feeding insects do not just steal energy. It is about preventing collapse. Without interruption, nutrient imbalances deepen, organic matter declines, and soil structure degrades, reducing water retention and increasing vulnerability to drought stress. The crop that should improve land health instead exposes how thin the margin actually is. What makes this unsettling is that none of these effects violate ecological rules. They obey them perfectly. The problem is scale and repetition. A system evolved for occasional presence is forced into permanence. The soil responds by becoming brittle. From a distance, soybean fields look calm, uniform, controlled. Beneath the surface, the system is under continuous metabolic strain, locked into a feedback loop that rewards short-term output while erasing long-term stability. Soybeans thrive not because they create balance, but because modern agriculture prevents the consequences from arriving all at once. Damage is spread across seasons and regions, making it feel manageable. But biologically, the limit is clear. Stay too long and the system turns against itself. This is why soybeans are rotated, relocated, and traded globally at massive scale. They cannot be allowed to settle. A crop that feeds the world does so by consuming the resilience of the land beneath it, one cycle at a time, until the only remaining option is to move on, quietly, before the soil remembers too much. Soybeans do not just move across land, they move across memory. Their global success depends on a kind of ecological forgetting, where landscapes are stripped of their previous complexity and reduced to a simplified state that can tolerate extreme repetition. This is the next contradiction. A crop that supports life on a planetary scale does so by requiring environments that have been biologically reset. Forests, savannas, wetlands, and mixed agricultural systems are not compatible with long-term soybean dominance. They must be removed, simplified, flattened into something quieter. What replaces them is not an ecosystem in the traditional sense, but a controlled biological surface, engineered to absorb stress without expressing it too loudly. Soybeans flourish in these conditions because nothing is left to compete, resist, or destabilize their narrow requirements. The cost is not immediate collapse, but absence. Pollinator networks shrink, soil food webs lose redundancy, trophic layers thin until only a few functional relationships remain. This does not look like destruction when viewed from above. It looks orderly, predictable, efficient, but efficiency at this level comes with a biological side effect. Systems that are simplified become sensitive. They respond poorly to surprise. Climate variability, pest migration, or minor shifts in rainfall timing produce outsized consequences because there are no buffers left to absorb shock. Soybeans thrive in these environments precisely because the system has been made forgetful, unable to remember how to respond in more than one way. This is why soy production expands most aggressively into newly cleared land, not because the soil is inherently superior, but because it has not yet been trained into fragility. Freshly converted landscapes still contain residual resilience, enough microbial diversity, and structural complexity to tolerate intense extraction for a time. Soybeans consume that resilience gradually, season by season, until the land becomes functionally dependent on constant management. Fertilizers replace lost cycles, chemicals replace lost predators, machinery replaces lost structure. What emerges is a system that appears stable only because every failure mode is actively suppressed. This is not an agricultural flaw, it is a biological trade. The crop feeds the world by operating inside environments that have been stripped of competing life. Soybeans do not coexist easily. They dominate, then require intervention to maintain that dominance. The unsettling part is how normal this has become. Entire regions are reshaped to accommodate a single species whose productivity depends on the erasure of complexity. The world eats well, while the underlying systems grow quieter, simpler, less capable of surprise. Soybeans succeed because they are grown where ecological memory has been deliberately erased, and because once that memory begins to return, through disease, instability, or declining yields, the solution is rarely restoration. It is relocation. New land, new soil. Another place that has not yet learned what long-term soybean presence feels like. In this way, soy does not just move nutrients or calories. It moves the boundary of ecological exhaustion outward, leaving behind landscapes that function but no longer remember how they once sustained themselves. Soybeans appear stationary. Rows align, fields repeat. But biologically, they are never meant to belong. This is the contradiction hidden inside their design. Modern soybean varieties are selected for yield, uniformity, and responsiveness to control, not for long-term coexistence with a specific place. They are optimized to perform intensely for a short window, under tightly managed conditions, then disappear. When soybeans are asked to stay, the limits show quickly. Pests adapt faster than breeding cycles can respond. Fungal pathogens accumulate genetic familiarity with their host. Nematodes exploit the predictability of root systems that return year after year. The plant has no evolutionary memory of permanence. It was never selected for that. Its survival strategy is not endurance, it is throughput. High conversion of sunlight, water, and nutrients into biomass, followed by removal. This pushes the system to an extreme edge where timing matters more than balance. Soybeans succeed when every variable is synchronized. Planting windows must be precise, moisture availability must be managed, soil chemistry must be corrected constantly. There is no tolerance for drift, small delays compound, minor stressors cascade. What feels unsettling is how little room there is for error. A crop so central to global food systems operates with almost no biological buffer. When soybeans are moved to new regions, they often perform exceptionally well at first. Yields spike. Inputs appear efficient. This creates the illusion that the system is robust. In reality, it is burning through inherited stability left behind by previous ecosystems. As seasons pass, that inherited resilience fades, and the same patterns emerge again. Rising disease pressure, declining soil structure, increasing dependence on external inputs. The plant itself has not changed. The land has been pushed closer to its threshold. Soybeans do not collapse systems instantly. They reveal limits by approaching them quietly, repeatedly, until management replaces ecology. At that point, the field still produces, but only because it is being held together by intervention. The crop is no longer integrated into a living system. It is suspended inside one. This is why soybeans feel more like a mobile industrial process than a traditional crop. They extract value efficiently, but only if allowed to keep moving. Belonging is not part of the equation. The moment soybeans are treated as a settled presence, the system begins to fail. Not dramatically, predictably, slowly enough to be normalized. A plant that feeds the world does so by refusing to form lasting relationships with the places it grows. It is productive because it is temporary, and that is the condition that makes its global dominance possible and quietly unstable at the same time. At this stage, the system looks controlled. Inputs are measured, outputs are predictable. From the surface, it appears that soybeans are fully contained by technology. This is the illusion. The deeper contradiction is that the more control is applied, the less biological autonomy remains. Soybean agriculture functions through continuous correction. Nutrients are added to compensate for imbalances the crop itself accelerates. Herbicides suppress competitors that simplified ecosystems can no longer regulate. Fungicides and nematicides hold pathogens at bay that thrive precisely because the host keeps returning. Each intervention solves a narrow problem while tightening the system further. This is not resilience, it is dependency engineering. The soil stops acting like soil and begins acting like a platform, a medium that must be constantly adjusted to keep performance within acceptable limits. If inputs pause, failure does not wait. The system has no memory of self-repair left to draw from. What makes this unsettling is how rational it feels. Every fix is logical. Every tool works, individually. Collectively, they form a structure that cannot tolerate absence. Soybeans are no longer growing inside an ecosystem. They are being maintained inside a continuous override. Climate variability exposes this immediately. Slight shifts in rainfall timing stress routes already operating near metabolic limits. Heat waves accelerate pathogen life cycles faster than chemical controls can adapt. Extreme weather does not need to be catastrophic, it only needs to be slightly off pattern. When that happens, the system does not bend, it slips. Yield losses appear suddenly, not because conditions are unprecedented but because the biological slack has already been removed. This is where the horror becomes quiet and procedural. There is no disaster moment. There is only escalation. More inputs, more management, more effort to hold the same line. Soybeans persist under these conditions not because they are robust, but because humans continuously intervene to prevent the consequences of over-optimization from arriving all at once. Control does not eliminate risk, it postpones it, spreading it across time, labor, and geography. The crop survives because the system surrounding it absorbs the strain. But that surrounding system is finite. Soil chemistry can only be corrected so many times before structure degrades. Pest resistance evolves faster than chemical innovation. Climate variability outpaces predictive models. None of this is unexpected. It is the natural outcome of a biological system pushed to operate without redundancy. Soybeans feed the world inside a framework that looks stable only because failure is being actively held back. The moment intervention slows, the limits reassert themselves. Not violently, inevitably. At a global scale, this system begins to reveal its final contradiction. Soybeans feed the world by narrowing it. As production concentrates into fewer regions and fewer genetic lines, efficiency increases while tolerance disappears. Most of the world's soy comes from a limited number of countries, grown from a surprisingly small pool of closely related cultivars. This is not accidental. Uniform genetics simplify harvesting, processing, and trade. They also remove biological insulation. When stress arrives, it does not encounter variety, it encounters sameness. Disease outbreaks spread faster, climate anomalies affect entire regions simultaneously. Market disruptions ripple through food systems that depend on soy not just as food, but as infrastructure, embedded into animal feed, oils, additives, and industrial products. The unsettling part is how invisible this dependence feels. Soybeans are rarely eaten whole by humans, yet they underpin modern diets everywhere. Their failure would not look like empty fields. It would look like cascading shortages, price spikes, and nutritional gaps appearing far from where the plants are grown. Biologically, this is a system operating with synchronized vulnerability. When soy works, it works everywhere at once. When it struggles together. There is no local buffer left. The world does not eat soybeans from one place. It eats them from all places at the same time. This pushes survival limits beyond ecology and into logistics. The crop's success depends on uninterrupted movement, stable climates across continents, and continuous industrial coordination. None of these are biological guarantees. Soybeans have become efficient not because they are adaptable, but because everything around them has been forced to adapt instead. The planet absorbs the variability so the crop does not have to. This inversion feels wrong because it is. Life typically survives by diversifying risk. Soybeans survive by externalizing it. When climate patterns shift unevenly, when supply chains fracture, or when disease pressure aligns across regions, the system does not have internal flexibility to respond. It has procedures, and procedures fail differently than ecosystems. They fail cleanly, quietly, and all at once. A crop that feeds billions does so inside a structure that cannot absorb surprise. The yield numbers remain impressive, right up until they don't. What makes this disturbing is not the possibility of collapse, but how little biological warning precedes it. Soybeans do not signal distress dramatically, they simply stop performing, and by the time that happens at scale, the system they support has already been narrowed too far to adjust easily. Soybeans ultimately survive by obeying a rule that feels backwards for life. They do not persist by adapting to place, they persist by ensuring no place has to adapt to them for too long. This is the final, uncomfortable resolution. A crop that feeds the world does so by behaving like a transient system, never settling long enough for the full biological cost to become unavoidable. Every field is temporary, every region is provisional. Productivity is highest where memory is shortest. When the soil begins to respond, when pathogens organize, when nutrient cycles tighten and resistance builds, the solution is rarely to slow down. It is to move on. New land absorbs the stress. New rotations delay recognition. New inputs postpone consequence. Soybeans are successful because the system around them is willing to remain in motion. This is not resilience in the ecological sense. It is momentum. As long as expansion, relocation, and intervention continue, the crop performs. The moment those processes stall, the underlying limits surface. Soybeans do not fail loudly. They fail by becoming increasingly expensive to maintain, increasingly sensitive to disruption, increasingly dependent on precision. A living system with no tolerance for pause. What makes this unsettling is that nothing about it is malfunctioning. The biology is sound, the chemistry is consistent, the outcomes are predictable. A plant optimized for extraction, grown at planetary scale, will eventually demand constant movement to avoid collapse. Soybeans feed the world because the world has been reorganized to keep them from staying still. Their global dominance is not a sign of biological harmony, but of a system operating permanently at the edge of what it can sustain. This should not be stable. A food system this centralized, this uniform, this tightly managed should be brittle. But for now, it works. And that is the most disturbing part. The system holds together not because it is balanced, but because it has not yet been forced to stop moving.